Hi, Assalamualaikum. My name is Muhammad Zahruddin. So today, me and my friends will present our autonomous firefighter robot project. To start, our project, we built a completely autonomous firefighting robot that can assist with a variety of fire situations in homes, office, and enterprises. This robot's main purpose is to serve as an main support vehicle that can search for and extinguish fires. To achieve so, we will describe the design process and execution of our fire extinguisher robot. In this project, we use a smoke sensor for fire detection to make the robot more efficient in extinguishing the fire. Multiple control system and other required components such as ultrasonic sensor have been installed, which is to detect any obstacle near the robot. Okay, so generally our robot is programmed in Arduino to send the data obtained to the microcontroller once the sensor detect fire, and after that, by using a DC motor pump and a servo motor, the robot will begin extinguishing the fire with the water from the water tank. The water tank's flexible pipe is connected to servo motor, will allow the robot to spray water at angle ranging from 10 to 170 degree. Okay, and on the other hand, the ultrasonic sensor is to help the robot in movement, which to give signal to the robot whether to turn right, turn left, move forward, or stop. Okay, so we move to the circuit design. Here we are using three ultrasonic sensor. First, a smoke sensor, one battery, one L293D motor driver controller, 3 DC motor, where two of them to move the robot the fire location, and the other one is to turn on the water pump to extinguish the fire. And lastly, we use the micro servo to allow the hose pipe to rotate in reverse direction continuously from 10 to 170 degree. So, based on the circuit diagram here, we had successfully connected all the component pins to the microcontroller. So now, this is our design. All the component has been built along. As mentioned before, during circuit design, we put the ultrasonic sensor at the front, left and right of the body robot, while the smoke sensor above the front ultrasonic sensor. Two DC motor been attached with the right left tire to, and both of the tire act as an active tire. Another one tire is a passive tire to balance the robot. We move to the above part. Okay, so we designed a water tank along with the DC motor and water pump. Also located there is the pipe and the servo motor. Okay, now, my friends, we will continue the presentation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nisa Idina Shafika binti Samsul Kamal. Okay, so today I'm going to continue the presentations by explaining the truth table. Okay, so now we had created the truth table to make our fire extinguisher robot motion planning. We had included all the main things that needed to move our robot successfully. As we can see in the table, we had set the details for each main components that help to move our fire extinguisher robot and to extinguish the fire system. The conditions motion plan for our robot are move forward, turn right, turn left, stop when the robot detects fire, which when the smoke sensor detects above 20 ppm of smoke, and lastly stop when the robot reach at the end of the road. Okay, so now presenting here our flowchart. We did our flowchart based on the truth table we created to ease the process of our work. So we had implemented the programming using Arduino language for the microcontroller of the robot. So the idea is the sensor will initiate and check for the conditions for ultrasonic sensor and the smoke sensor. So if a fire incident happens in any place, the smoke sensors will detect and provide notifications to the microcontroller. Once fire detection is confirmed, the microcontroller will inform the control unit, then the robot will instantly stop and turn on the water pump. Okay, same goes to the movement of the robot. The ultrasonic sensor will detect the obstacles by sending the distance of the robot to the wall to the microcontroller, so the robot can detect whether to move forward, turn right, turn left, or to stop following the distance that has been programmed. So based on our result, we had simulated the circuit to check whether the robot is function as what we've been programmed. So the first condition, as we can see here, once the smoke sensor detect value above 20 ppm, the DC motor and the servo motor is turned on to to extinguish the fire while both the DC motor are instantly stopped, which to stop the robot. Okay, so next, the robot has been successfully moved forward when all the ultrasonic sensors follows the distance that we've been programmed, and also when the smoke sensors is not sensing any smoke area below than 20 ppm. So we can see the value of the both DC motor is the same, since we set the same speed for both of them when moving forward, and the DC motor for water pump is turning off. Okay, so we move to the third case where the robot is turning right. Okay, when the right ultrasonic sensor detecting the distance robot to the wall below than 17.5 centimeter, which is the right dimension to move forward on the hallway. So we can see the right DC motor is a bit slower than the left DC motor, and the DC motor for water pump is still turning off because it's not detect any smoke below than 20 ppm. Okay, so now is the last case when the ultrasonic sensors not detect any obstacles or wall below than 17.5 centimeter distance from the robot to the wall. So the robot will stop immediately, which means it already reached at the end of the hallway. So basically all the coding we've been programmed and the circuit we've been connected are successfully working, but in the future we should consider some advancement to the robot, which the robot should be installed the camera, and also can send the notifications to the user as when the fire detected. Okay, so that's all from us. Thank you.